Welcome. My name is Craig Gundry, and I'm the Vice President of Special Projects for Critical Intervention Services and the lead architect of the CIS Guardian SafeSchool Program. In the last video, we discussed the pathway to targeted violence, threat assessment principles, and managing student behavior of concern. In this video, we'll explore important aspects of physical security, life safety design, and response to imminent threat situations. When many people think of physical security, the first thing that comes to mind are things like CCTV cameras, alarm systems, locks, and other similar types of hardware or system components that we associate with security functions. When I think of physical security, the first thing that comes to mind is mathematics. Physical security fundamentally is about reconciling key times and probabilities in a mathematical way whereby a response force is properly alerted, deployed, and can intercept an adversary before they can accomplish their objective. Now, one of the biggest problems that I encounter working with schools isn't so much specific deficiencies with different hardware components, although we'll explore that as this module continues, but it is usually the failure to reconcile these various different variables in a way that our response force can effectively stop an active shooter before mass tragedy occurs. Now, there are three key system functions which must all work together integrally to accomplish this objective. These are detection, delay, and response. Now, to define physical security in most basic lay terms, detection must be reliable and occur early enough to provide for response. Second, delay elements are then used in order to slow down an adversary's ingress to provide opportunity for that response force to deploy. Then the response force must be properly alerted and dispatched and capable of intercepting that adversary before they can accomplish their objective. Now, when we talk about school security, this delay function is primarily facilitated by physical barriers, things like our doors, walls, locks, and windows, and other similar types of barrier systems, distance that the adversary, or in our primary concern in schools, active shooter, must traverse before they can access those individuals that they're trying to target, and also the protective actions of the people within that environment, things that they do to put distance between themselves and harm, such as evacuating from the campus or taking refuge inside of a secured room. Now, our detection function generally is usually going to be facilitated by visual or audible attack recognition. Somebody who saw the gunman crossing a parking lot or who heard the gunfire. It is possible we may also be employing automated systems, such as gunshot detection sensors, or possibly also manual alert systems, such as panic alarms. And then there's also the communication systems that our response force employs, such as the communication function provided by the 911 call center, by our telephone systems reaching out to the 911 call center, or to an on-site security control room if we happen to have one of those in our school. And then the response function is typically facilitated by the 911 center that is coordinating the actions or the dispatch of those officers, or the security control room that may be facilitating a similar function in schools that have one. The on-site school resource officers or armed security officers, or if we don't have an on-site response force, the off-site law enforcement officers that are going to be dispatched to our school when an emergency is detected. Now, bringing this back to the subject of mathematics, the fundamental or the principal performance metric of any physical protection system is what's called the probability of interruption. This is the probability that when an intrusion is detected, a response force can be reliably alerted, dispatched, and capable of intercepting that adversary before they can accomplish their objective. It essentially factors all these different elements that we've been discussing. Now, to put this kind of into context as it relates to active shooter attacks, the time that starts the clock on response isn't so much when an adversary arrives on campus, but the moment that they are in fact detected and somebody initiates the first initial alert. That is represented in my diagram by the letters TD as time of detection. Then we have a time period where whoever it is that recognized this intrusion is reporting it to the 911 call center or to the on-site security control room, and it is recognized as being an attack, and whoever it is that's receiving that report, capable of dispatching the alert force, recognizes that it is in fact a live event. And that is represented in my diagram by TA, time of assessment. Then there is the dispatch of those officers and their deployment, travel time, to the actual scene, and then once they arrive on scene, identifying the location of the, in this case, adversary, the attacker, and then moving to that individual's location capable of neutralizing that adversary. And that is represented by the letters TI, time of interruption. Now, our ultimate aim is to have a TI less than TC, which would be, in this example, the time that our adversary, from having intruded into the facility, accesses the student population and commences mass killing. So what you see represented in the diagram right now is an effective system. TI, time of interruption, occurred before time of completion when the adversary initiated mass homicide. Unfortunately, what we usually encounter in most previous school shooting events is a situation like this, where TI occurs after TC, where mass killing has commenced before that response force is capable of effectively intervening. And we can estimate what the consequences of this variance is at 1 casualty on average per 15 seconds, according to several different studies. Now, in a perfect design, if we were to effectively integrate these different elements, detection, delay, and response, TI, again, would occur before TC. Now, could we accomplish that in the real world? Absolutely. In fact, at the end of this module, I will show you how we could adjust elements looking at a previous case scenario to accomplish this objective. However, quite often in the real world, especially when we consider that we could have insider adversaries that are already within the school, which limits the amount of available delay in terms of barriers, well, our ultimate aim is to narrow the gap between TI and TC. Again, with the benefit, potentially, theoretically, of 1 casualty every 15 seconds. Now, when we look at real-world events, we can see how these different times actually kind of played out. One example was the attack at the Marjory Stoneman Douglas High School in Parkland, Florida, where Nicholas Cruz arrived at MSDHS High School in an Uber, walked through an unmanned or unstaffed pedestrian entrance gate at 1419. He then entered the east hallway doors of Building 12 at 1421, 2:21 p.m., and within a matter of less than a minute, initiated mass killing. First rounds were fired according to the MSDHS Commission report at 14:21:38. Then, by 14:27, the last shots were fired. Now, during that 5.5, 6-minute time period between the first floor of the building and his progression all the way up to the 3rd floor of the building, 17 people were killed and 15 wounded. And then Cruz departed the building at 14:28. Now, the first call to 911 was received at 14:22. Now, in this case, the on-site school resource officer, Deputy Peterson, wasn't necessarily reliant on a 911 dispatch. It was aware that something was going on campus and moved to the location of the building, and that was at 14:23. At 14:23, police were also dispatched in nearby jurisdictions to MSDHS High School. And actual arrival time was very, very shortly thereafter. In fact, Peterson arrived at 14:23. The first initial arriving units from outside of the school also arrived on scene within about 60 seconds or so thereafter. However, as a result of the actions of the deputy on scene, delaying officers from entering into the building, it wasn't until 14:31 that the first officers actually entered into building number 12, tactically prepared in order to intercept Cruz. However, he had already escaped from the building by that point. That makes, for all purposes, the on-scene response time 1.65 minutes. and the effective response time is 9 minutes. Now, this is an important point I want to emphasize. The FBI conducted a study a number of years ago looking at active shooter events between the period of 2000 to 2013. They published a report based on this and have been updating it annually ever since. There also was an analysis of that data that was published separately. And one of the things that they looked at was response times in active shooter events. Now, they didn't have response time data for all events, so it was a subset of the total amount that were looked at as part of the initial active shooter study. Now, in that report that was published, it was stated that the average response time for law enforcement in these events was about 3 minutes. Now, that actually kind of caught me by surprise when I saw that. And then I realized that was the on-site response time. That was from the time of dispatch to the time that officers were actually on scene. That actually is quite common. However, what we often see in these events then is an additional 4 to 5 minutes time as officers assess the situation, in many cases organize into contact teams, and then move to the location of the actual adversary. Thus, what really matters to me isn't the on-scene response time, isn't the time that the officers arrive, but the time that they actually entered into that building and were tactically ready in order to stop the active shooter. Now, another example of this kind of situation occurred at Sandy Hook Elementary School, where Adam Lanza breached the exterior glass window adjacent to the main entrance door at 0934. He then passed through the lobby, engaged several staff members in a hallway, proceeded down that hallway and entered into classroom number 8, the first classroom where mass homicide commenced. That was at approximately 0935. And then within the next 5 minutes, by the time he committed suicide at 0940, 26 people were killed altogether, students and faculty members. That makes the adversary task time in this event, similar to the Parkland situation, less than 1 minute. Now, the first call to 911 was made at 0935. Dispatch times documented by the Connecticut Attorney General's report, 0936. And the first responding officers arrived on scene at 0937. Now, again, that was a remarkable on-scene response time, estimated 2.5 minutes from the first call to 911. However, by the time they organized into a contact team in the parking lot, assessed the situation, and found a point of entry into the building, and moved to Lanza's location, put them on arrival at his location at 0944. That again makes the effective response time 9 minutes. Pretty much exactly the same thing that we saw in the Parkland shooting. Now, if we were to continue looking at these events, breaking down the adversary task times and the response times, considering the first calls to 911, police dispatched, or school resource officer deployment to that location, and by the time that they make entry, we're going to continue to see this similar trend. Adversary task times estimated 1 minute. Effective response times usually ranging somewhere between around 7 minutes to as long as 12 and 14 minutes in some cases. And then we have historical events which resulted in some significant tragedies, like the Columbine High School shooting, where we had an effective response time of 110 minutes. Now, in order to accomplish this objective of narrowing the gap between adversary task time and time of interruption, or what you saw in the last slide as the effective response time, there's a number of things that we want to try to integrate into our security design. The first is making sure that we're delaying the adversary's ingress into populated areas. The second is early detection of the threat and rapid alert communications. Ideally, detection before mass killing commences. Then, rapid alert to the response force that's capable of actually intercepting that adversary and neutralizing that adversary. Whether that's on-site school resource officers, perhaps armed security officers on site, or perhaps that may be an off-site response force, such as police dispatch from the local community. Then also, rapid alert to faculty and students so that they can initiate protective actions for their own safety. That may mean escaping from campus or perhaps barricading inside of classrooms that are intrusion resistant, in essence, entering into a lockdown state. Then we also want to consider measures to facilitate the rapid egress or escape of people from the hostile environment, those that are unable to actually take refuge inside of a safe classroom or activity room or some other location. That also, in essence, is a form of delay. It allows them to put distance between themselves and the adversary, and then reduce the effective response time by rapidly deploying a response force capable of neutralizing the threat. And that addresses the response function of our physical protection system. So if the circumstances permit having an on-site response force, that will have one of the largest impacts in improving the overall performance of our physical security system. And I'll kind of circle back around on this a little bit later on when we get to the integration of these different elements. Now, in most schools, we can conceptually think of the design of our barriers and detection elements as multiple layers, what's referred to in physical security design as protective layers. And in most schools, we have 3 protective layers, sometimes maybe 4. And I've also encountered some schools that technically maybe had 5 protective layers, but for simplicity's sake, we'll address this as 3 layers, which addresses the most common types of barrier layers in most schools. The first protective layer is the exterior campus perimeter and encompassing the outdoor grounds. The second protective layer would be the building envelope around our student-occupied school buildings. And then the third protective layer, which would include any type of classrooms, activity rooms, or perhaps even staff offices, which are adequate for lockdown purposes. In other words, that they are intrusion resistant and can provide some useful delay in slowing down an adversary or deterring an adversary from accessing the students taking refuge in those rooms. Now, starting with the first protective layer, many schools around the nation have been installing perimeter fencing as a means of trying to deter adversaries from entering and providing useful time for attack recognition and response. Now, if we are going to be implementing a fence perimeter, I think it's important to kind of understand what its limitations are. What can we actually expect performance-wise from that, as well as also some of the hazards or some of the risks associated with installing that fence. Now, if one of our primary objectives is to reduce the amount of non-malevolent trespass, let me pause for a moment and just kind of clarify that point. A number of independent schools that I've worked with in recent years had campuses that were located in urban environments where many residents in the nearby community would actually trespass through their campus, not with any kind of intent, at least as far as criminal intent, but instead just as a shortcut to get from point A to point B on the other side of the campus. So if we have this type of situation, then obviously campus fencing or other similar types of barrier systems like a wall or something like this can assist us in managing this particular concern. Also, if we're primarily concerned about criminal activity, such as vandalism, theft, or other similar types of activity on our campus, then campus fencing is often quite effective at least deterring non-committed criminal trespass. Now, if we're concerned about active shooters, however, we're quite often dealing with a committed adversary, somebody that's targeting the school for very specific reasons. Do not fall under the belief that having a perimeter fence alone will stop an active shooter from coming into your school campus. What is a barrier like a fence? Now, quite often when I ask that question of lay people, when dealing with clients, the answer that many people give is that it stops somebody from coming in. Well, a fence, and this is true for all barriers, walls, locks, doors, windows, all this stuff. A barrier does not stop anybody from doing anything. All it does is delay them from doing it. Good example, a 7-foot tall chain link fence attached to a bottom rail with a barbed wire top guard, according to Sandia National Laboratories, only has a mean delay time of 8 seconds against an adversary with gloves. That is its true performance measure in a performance-based physical protection system. Also keep in mind that the practicality of installing fencing around a campus hinges on several different factors. One is the size and the layout of the campus. Two, the volume and entry of exit activity within the campus. Now, if we have a, say, single division school, we do not have a lot of different various activities occurring on campus where we're going to have a lot of outsiders, which would be difficult to vet on a continuous and daily basis. Then perhaps perimeter fencing may be feasible, may work. On the other hand, if we have a very, very large campus with a high volume of diverse activity, especially if we have a lot of different types of activities that are outside of the normal academic schedule, then this could actually get quite challenging and be, in some cases, somewhat impractical. Also, I would add to that outdoor monitoring capabilities. Now, if we were to speak with the experts in physical security design out at Sandia National Laboratories and ask them what the value of a barrier at a perimeter that has no detection elements, they will tell you 0. Has no value whatsoever in the physical security design. Barrier delay only matters after detection occurs. So if we have a very, very large perimeter and for all purposes, it is not being monitored consistently, then that perimeter fence should not be considered reliable for the purposes of our overall integrated physical security strategy. Now, let's take a look at an example of where perimeter fencing may be feasible and may provide useful benefit, and another one where, from a cost-benefits perspective, may not make sense. Now, on screen is an example of a small single-division school where all buildings within the campus are relatively tightly located, with only small areas in between buildings, primarily walkways. In this type of situation, installing perimeter fencing with appropriate gates in order to enclose those walkways, creating for all purposes a single contiguous protective layer, will provide useful delay in this case, may permit children to be located outdoors or move between classes while not being directly exposed or to an intruder just, at least entering inside of that campus courtyard area unimpeded. Also, considering the tight quarters of the buildings in this school example, the probability of detection if somebody does attempt to climb that fence is relatively high. So if I was working with this school, perimeter fencing would be something that I might recommend. Or if they proposed it to me as one of their considerations, I would probably endorse it in this case. From a cost-benefit perspective, it makes sense. Now, on the other hand, in this example, we have a multi-divisional school with multiple buildings that are spread out over a much larger geographic area. We also, in this expanded campus environment, have 2 public roads entering inside of the campus. And this type of situation that you're seeing on screen right now, this is actually a very common type of scenario I encounter with independent school clients. Now, if we were to try to establish a fenced perimeter around the whole outside, that would encompass a number of different problems when we look at it from a cost-benefit perspective. The first, that's a huge amount of perimeter area that needs to be fenced. That obviously is going to entail a very high degree of cost. Second, we got very large sections of the perimeter that are unattended, located away from where students and faculty are located at, and without installing CCTV cameras that are monitored live and/or intrusion detection sensors, it is unlikely that if anybody tried to climb that perimeter fence, that we would have any kind of useful delay there. Also, requires building and staffing. Now, consider those public roads for a moment. It does require that if we're going to facilitate vehicle entry into the campus, that we actually have some type of guardhouse that is validating entrance upon arrival. Now, I know a number of campuses that do this, closed campuses. Truthfully, in a large percentage of situations, if there is a large volume of diverse activity, different types of people coming on campus for different kinds of events, quite often what ends up happening is a scenario where the guard sits in that guardhouse and just basically smiles and asks questions of people upon arrival, often with very little vetting and beyond that. In essence, very ineffective. So instead, we may end up entailing this high cost of actually building that guardhouse, and then, of course, the operational cost of staffing it without really accomplishing much risk reduction. So when I sit there and I look at all the different factors in this scenario, from a cost-benefit perspective, quite often I would rather see this school spend their money on other upgrades which are more likely going to achieve a higher level of performance. So in essence, very expensive and unlikely to provide meaningful delay considering the very low probability of detection. Now, if we do employ some type of fenced campus perimeter or some type of other barrier system around the outside of the perimeter, we want to make sure that we provide adequate availability of secure egress gates so that people that are located outdoors can effectively escape from the campus. This is actually a big problem with many schools that I assess that have existing fence perimeters. Instead, they maybe have one or two primary points of entrance and egress. Now, for entry purposes, we do want to restrict entry in a fenced campus perimeter to a limited number of entrances, but we should have abundant availability of egress gates around the outside so that people that are located anywhere on campus can access a gate and escape from the campus without having to circle back around to a restricted number of entry points. Now, if we're concerned about our egress gates being exploited for entry purposes, there's some things that we can do to protect those gates. A simple design for a secure pedestrian egress gate would have a mechanical exit bar so that it can be easily manipulated by students for exit purposes. Now, if we are concerned about younger children, perhaps in an elementary school, escaping, or exiting the campus without being recognized by an adult, then using an audible alarm or mechanical exit bar with an audible alarm could address that problem. I would also ideally recommend having some type of boldly visible exit sign, as well as exit signs along the perimeter directing people to the nearest egress point. Anti-manipulation features to prevent somebody from reaching through and manipulating the exit bar. And that can be simply accomplished by having some type of acrylic panel on the outside or some other similar type of tight mesh screen material that would prevent somebody from either reaching through by hand or with an object to manipulate the exit bar. And I would also, as a practical measure, recommend having a strong spring closure device that will securely close that gate after it's been opened. And that in the real world is a common thing that I've seen in a number of fenced campuses, is that over time the spring closure will often weaken, and as a result somebody exits out that gate, the gate just falls back and then sits without fully engaging the latch. Now, whether we're using a perimeter fencing to create a closed campus environment, or even if we have an open campus, there are some additional measures that we can also use in order to reduce the potential for crime on campus. One approach to this is a strategy called crime prevention through environmental design, also referred to as CPTED. CPTED fundamentally employs diverse environmental design approaches in order to increase fear of apprehension by criminals. One example would be landscaping that limits access points and defines the actual perimeter of the campus. This will also help reduce or discourage casual trespass, such as people passing through our property. Having unobstructed sight lines, what's called natural surveillance, permitting people to easily see if somebody is at a place where somebody's engaging in some type of criminal activity, like stealing a car or perhaps laying in wait for the purposes of attacking, somebody passing down a walkway. Good illumination. The International Illumination Engineering Society has guidelines for illumination in different types of environments, like walkways, parking lots, as well as a lot of different types of indoor applications, parking garages, and things like this. Without getting overly detailed, I would at least recommend that most spaces where students and visitors to the campus are likely to walk, such as parking lots, walkways, areas between buildings, etc., that they are illuminated to at least a level of 3-foot candles or greater. That will at least provide adequate illumination for recognition of activity and subject identification, where the guideline is 2-foot candles, but then also improves the perception of safety in the environment for those students that happen to be outdoors at night. and then having adequate signage defining property ownership to discourage casual trespass. And if we have CCTV surveillance around the outside of the campus, putting signs up that this campus is under video surveillance will also help discourage criminal activity. Now, outdoor playgrounds and athletic fields should ideally be concealed from off-site locations by some type of opaque fencing or through the use of landscaping features, like dense hedges and things like this. My concern in this situation in the attack at the Ozar Hatorah School in Toulouse. This was executed by a terrorist by the name of Mohammed Merah, attacking a Jewish school. When he first arrived and got out of his vehicle, basically we had a number of students that were playing outside, as well as a rabbi and his two sons. And before anybody could recognize what was happening, Merah had already raised his rifle and began opening fire, in essence, catching everybody in an ambush outdoor by surprise. To help reduce this potential risk, employing opaque screening around areas where students are quite frequently located, and playgrounds tend to be very common locations like this, athletic fields, outdoor eating areas, such as outside of our cafeterias, and any other kinds of courtyards where our students typically congregate would be a recommended practice. This at least reduces the likelihood that somebody can pull up into a parking lot or a street outside of our campus, get out with a weapon, aim, and begin firing before anybody sees what's happening. Now, this doesn't prevent the adversary from walking over to the fence and maybe shooting over the top of the fence, but at least it causes them to execute some type of action that we may recognize our teachers located outdoors and perhaps even our older students, that would warn them of the fact that something is occurring and provide a few seconds of opportunity in order to initiate an escape response. It is also recommended in an effective design that we have detection assets located outdoors to recognize intrusion or at least when an attack commences outside. And that could be done through a variety of different means, but could buy very valuable time for us to initiate building lockdown activities and to initiate the response force before that adversary even gets inside of a building. Now, one way that this can be accomplished is with the use of gunshot detection sensors. Gunshot detection sensors detect gunfire when an attack is commenced. Now, there are several different types of technologies that are available here. We have some systems that are regarded as optical, meaning that they detect the actual muzzle flash when the weapon is fired. The second are electro-optical systems. They detect the heat emitted by the muzzle flash or or at the muzzle when the weapon is fired. And then we have acoustic systems, which recognize characteristics of the sonic signature when a weapon is fired. And then there are many models of these sensors out in the market that actually are dual tech, utilizing one or more of these two of these technologies in a complementary way, so that both sensor technology A and sensor technology B detect a signal before it generates an alarm. These are primarily employed in order to reduce nuisance alarms. Now, many of the models of these systems that are out there on the market feature independent monitoring and alerting systems. In other words, a standalone software package or perhaps a monitoring system or station somewhere that when a gunshot signal is detected, audibly listens to it to verify the fact that it is a gunshot before it initiates some type of alert. Other types of sensor systems can just simply integrate with an existing security management software, such as Secure 9000 or some other similar type of system that integrates intrusion detection sensors. Truthfully, that latter approach is my preferred option when it comes to gunshot detection technology. Instead of having some type of off-site monitoring station that is going to verify the alarm. Because by the time that they verify it and by the time they alert the police, we may be talking a period of 10, 15, 20 seconds, which reduces, for all purposes, the practical value provided by those gunshot detection sensors. Now, in most campus environments, our second protective layer is going to be the envelope of the buildings themselves. And that includes the wall section around the outside of the building, as well as any kind of glazing, windows for instance, doors entering into that facility, and technically also includes the roof and any other additional kinds of accesses into the building. Now, first floor classroom and hallway windows, any kind of locked exterior doors, and any glazing adjacent to main entrances should be constructed with barrier materials that are capable of delaying forced entry. Now, when we specify barriers and we are talking about delayed or delay time or forced entry resistance, one of the key questions that comes to mind is what is the tool and the method that the bad guy is using in order to breach that barrier? That ultimately is going to determine its performance. When we're talking about active shooter attacks, I am primarily concerned about an adversary using firearm-aided penetration and direct physical force, such as beating their way through with a rifle buttstock or perhaps kicking, something like this, as the primary modes of entry. I have been studying these types of events, not just active shooter attacks in schools, but terrorist attacks globally and workplace violence shootings for almost 30 years now. I can only remember a handful of examples over the years where adversaries showed up with tools specifically for the purposes of breaching barriers, such as crowbars, fire axes, or anything like this. Usually our adversary shows up armed with weapon, maybe also with a bladed weapon too, like a knife that could be used for entry purposes, and then relies off the firearm penetration of that barrier and then direct physical force as the means of trying to penetrate through doors or other similar types of obstacles. So with that, what we call design basis threat or threat definition in mind, we can specify barriers that would appropriately provide intrusion resistance under those conditions. Now, one of the greatest concerns that I run into in many assessments of schools is extensive use of tempered glass glazing in exterior facade design. Tempered glass, keep in mind, is considered to be impact resistant. It's considered to be safety glass. And most of it is rated under impact resistance standards in such a manner that if somebody was to bump into it with an object, it will not break. But that impact resistance does not factor somebody that is intentionally trying to forcibly enter through that window. Also does not account for the fragility or how weak a tempered glass window gets when first penetrated by firearm projectile. We conducted, my organization, Critical Intervention Services, in cooperation with the window film manufacturer, SolarGuard, conducted tests of unprotected tempered glass windows, utilizing a firearm in order to penetrate through those windows and then enter through the breach. And the average mean delay time was 10 seconds. And in fact, that delay time is even less than the delay times originally clocked by Sandia National Laboratories decades ago when they were evaluating tempered glass windows against hand tools. And part of that is because Sandia did not account for the fragility of tempered glass when it's first penetrated by firearm projectile. And that is exactly how Adam Lanza entered Sandy Hook Elementary School in 2012. He didn't try to enter through the locked front entrance door. He just fired one shot through the adjacent tempered glass window, broke it by hand, and then stepped through the breach. Probably took him, again, no greater than maybe about 10 seconds, 9 seconds worth of time in order to enter into the school. Now, this brings up an interesting question. How much delay time does a barrier need to provide useful performance in an attack situation like this? Well, the textbook answer to that would be, cumulatively as a system, all these barriers and distance would provide enough time that a response force could deploy and intercept that adversary before they could accomplish their objective. In essence, before mass killing was in progress. Now, that's the textbook answer. In practical terms, I am at least looking for barriers that can provide useful delay, typically 45 seconds or more of delay, against an adversary utilizing a firearm and direct physical force to try to breach that barrier. Quite often what happens when we study the behavior of attackers in these situations is that if they can't make entry within that time period, 45 seconds, they will usually abandon that particular barrier, that door, window, whatever it is, and then continue moving in search of a more easily accessible target. That observation was also made by Smith and Renfro in an article that they wrote on physical security and building design on the World Building Design Guide online. They also made the exact same observation that quite frequently adversaries will not commit significant effort in order to specifically breach particular barriers, instead recognizing that the clock is working against them on response, looking for easy targets. Now, while that statement is true, we have had some events in different parts of the world where adversaries did commit effort to enter into secured rooms in order to attack the occupants of those rooms. And almost all of those events that I am familiar with involved situations where security forces arrived on site, set up a perimeter around the outside, and then waited. They did not make direct entry into the building in order to neutralize those adversaries. Because what happened in those situations was the terrorists, and almost all these were terrorist attacks, eventually ran out of targets. And at the point that that happened, and they realized that security forces weren't making entry, they suddenly realized they had time. And at that point, they started going back to secured rooms, trying to forcibly enter into those rooms in order to attack the people that were hidden inside that they suspected were located there. But these have been largely rare events, and they've also been mostly outside of the United States and Europe for that matter too. Good example, was terrorists trying to forcibly enter into hotel rooms in locations like the Intercontinental Hotel in Kabul, or inside of the Corinthia Hotel in Tripoli, or inside of the Taj Mahal Hotel in Mumbai, and other similar types of locations. It was usually where there was a delayed response, either because police set up a cordon outside or because it was such a large and complex building that they had difficulty locating the adversaries and navigating to their location. Now, there are several different types of glazing materials that can provide the kind of intrusion resistance that we're looking for. The first, and my preferred option, is laminated glass. Laminated glass is constructed of a PVB or polycarbonate interlayer that is then sandwiched between layers of glass. It is, by virtue of design, some of the most intrusion-resistant glazing available on the market. And quite frequently, even thin layers of laminated glass will provide delay times well in excess of 45 seconds. In fact, 1/2 inch laminated glass, according to Sandia National Laboratories, will resist hand tool attack or entry through the use of hand tools by over 2 minutes. If you are located in Florida, most newly constructed schools in Florida are constructed with laminated glass windows. That is a requirement under hurricane codes in the state of Florida. However, quite frequently in other locations throughout the country, that is not the case, and it is quite often just tempered glass windows. Wired glass. We don't ordinarily encounter wired glass in outdoor applications. Where we most frequently find in schools wired glass is usually door vision panels. Wired glass is not a security glazing. It is actually safety glass. However, it does provide better intrusion resistance than tempered glass, typically in the order of maybe around 20 to around 30 seconds of delay time. And my rule on that basically is that if a school already has existing wired glass windows, I usually don't recommend that they upgrade them at that point. Unless, of course, they've got an ample budget and we have already taken care of a lot of other more critical vulnerabilities. Acrylic glazing is another option, although truthfully, acrylic glazing does not really provide very good intrusion resistance. Only marginal performance improvement over, say, tempered glass windows. Now, a different type of polymer-based material, polycarbonate, does, however, have excellent intrusion resistance. One of the more common trade names for polycarbonate glazing is Lexan. As it is essentially again, polymer-based material. It has about 300 times the impact resistance of glass. 1/2 inch polycarbonate can resist hand tools all the way up or hand tool attack all the way up to 2 minutes, according to Sandia National Laboratories. Some of the other advantages of polycarbonate is sold in sheets. It can be easily cut to different required dimensions, edged with sandpaper, and then installed for retrofit applications. A good example of where that may be beneficial is replacement of door vision panels on classroom doors. Instead of purchasing laminated glass to size, we can just simply purchase large sheets of Lexan with appropriate thickness, cut them to appropriate dimensions, edge them with sandpaper, and then they can be installed or retrofit by our maintenance team or our contractor. The major disadvantage, however, of polycarbonate is that it is vulnerable to degradation from ultraviolet exposure. So generally, we don't want to employ polycarbonate in outdoor applications, unless it has been specially treated for that purpose. However, the cost of UV-treated polycarbonate is almost double the regular price. And once we get to that kind of price range, we may as well be opting for laminated glass. Another disadvantage of polycarbonate is it is not very resistant to scratch. So if we're installing polycarbonate in areas where we have a high volume maybe of students passing with book bags that could be brushing against it, probably within a period of time, maybe 6 months to a year or two, it's going to start getting a lot of scratches and will look unattractive. Another option for upgrading existing tempered glass windows, and in some cases, especially if we have a lot of windows that need to be addressed, can be one of the most cost-effective approaches to this, is installing anti-shatter film. Anti-shatter film is a film membrane that is adhered directly to the tempered glass window and then attached to either a separate framing system or attached to the existing window frame through the use of a special cement in order to retain that unit at the window when it breaks upon impact force. Relatively low-cost retrofit potential, has decent impact resistance. We actually conducted tests of anti-shatter film upgraded windows, and our delay times ranged anywhere from around 45 seconds to around 90 seconds on average. And that was employing a penetration tester that fired through the window first with a firearm and then started beating their way through with the use of an AR-15 rifle. And the images on screen right now kind of illustrate exactly what that breach looked like when our penetration tester finally got through. Now keep in mind that 45-second delay time that I mentioned a moment ago is the best time. That was the one scenario where my penetration tester actually turned the weapon almost into a hatchet and was beating through the weapon or through the window with extreme aggression. And in fact, he hit that window so hard that he actually bent the buffer tube of the rifle, which would have rendered that rifle actually inoperative. So if you were to be expecting a reasonable performance out of reinforced window or film reinforced windows, you could be looking at something around the 60-second time period. Now, although window film can be very effective and very cost beneficial in terms of upgrading a large number of tempered glass windows, there are some limitations to be aware of. One is it is somewhat vulnerable to heavy mass bladed objects, such as fire axes or machetes. Another disadvantage of window film, or I shouldn't say so much a disadvantage, a limitation we'll say, is it can only be installed in windows with appropriate frames. So if you have thin wooden frames, which I do encounter sometimes, particularly in older school buildings, you may not be able to use window film. It requires a proper attachment to the frame. Also, if you have, let's say, exterior glass doors with relatively thin frames, you will not be able to utilize window film. Although I don't encounter this often in schools, with my commercial clients, office buildings, I do encounter occasionally main entrance doors that are basically solid panels of glass at the top with no frame at all. In that case, you will not be able to use window film also. It would require actual replacement, probably with something like laminated glass. Now, ideally, our campus will be designed to channel access to one central visitor reception point. If we are in a large multi-divisional campus, we would ideally want to have an administrative building or some other similar type of location that would serve as that visitor control point, located near one of the main entry drives or somewhere else near perhaps a public parking lot where visitors, contractors, parents, and others would be expected to park. Now, if you're already working with an existing campus, that may not be feasible, and that's a common situation that I run into as a consultant. If that's the case, we want to make sure that we have ample signage throughout the campus directing visitors to that central reception point. Here's the problem that I'm trying to address with this. Quite often, if we are being vigilant in looking for possible intrusion activity, we want to try to reduce the number of nuisance alarms. In other words, people that have been recognized as being suspicious, who, when they're actually investigated, turn out simply to be parents or maybe contractors that were lost and didn't know where they were supposed to go. So quite often when I'm doing assessments on these types of campuses, I will look very attentively for where this signage is located at, if it's intuitive, and if it is likely that people will be lost when they're actually looking for the main office. Now, if we have a central reception point, a visitor control point, such as a main office, located inside of a building where students are located, we want to ensure that that entry control point, as it were, is designed as an independent protective layer in order to prevent somebody from being able to enter into that lobby and continue into student-occupied quarters unimpeded. This means essentially constructing a wall and door configuration that using intrusion-resistant materials that would isolate visitors at the actual entry control point, and then utilizing access control doors or other similar types of control measures in order to grant access between the visitor control point and the interior student-occupied areas of the building. Now, some schools that do not have a barrier configuration like this attempt to compensate for that by keeping the exterior door of the main office or whatever that entry control point is in a locked state most of the time. Truthfully, in most cases where I've investigated or assessed campuses that had this type of situation, it usually wasn't being implemented very effectively. Quite often, somebody would just walk up to the door, hit a buzzer, and speak with the secretary on the other side, often with an intercom or maybe with a camera, and as long as they didn't look like an overt threat, and whatever their explanation is made some kind of plausible reason, that door was automatically open and they were granted access to the inside of the school. Now, if we construct an interior barrier layer at that reception lobby, similar to what I'm describing, you can actually leave that door in an open state, or the exterior door, I'll say, in an open state. There's no reason to actually have a buzzer at that point or to require an intercom so that somebody can be vetted at the door by a secretary. Instead, that could be done inside of the lobby. Now, let me pause for a moment and note, studying previous active shooter events executed by outsider adversaries, a large percentage of attacks executed by outsider adversaries originate directly through main entrance doors and lobbies. And in fact, we witnessed this in the 2012 Sandy Hook Elementary shooting when Adam Lanza breached the exterior facade, the exterior glass window of the lobby, progressed into that lobby and through it unimpeded. Now, at the end of this lesson, we're going to circle back around on the Sandy Hook Elementary situation and look at some measures that we could have employed to improve delay time and to create a performance-based protective system in that situation. And one of those key measures you'll see me recommend is the construction of an intrusion-resistant wall and door system that would have isolated the lobby separate from the student-occupied quarters. Now, on screen is an example of, it's a before picture of a lobby. This is just immediately inside after entering through the exterior doors. We have the reception desk on the left-hand side, and you can see at the end of this a corridor that basically proceeds laterally. Now, if I was to continue walking past this reception desk, I could turn left or right, and I would be in classroom quarters. There's, for all purposes, nothing obstructing my progression from this visitor reception point. Now, in this image, you're viewing the upgrade that was done to that particular lobby. And now we actually have an intrusion-resistant wall, intrusion-resistant doors constructed from intrusion-resistant glazing, laminated glass, and then controlled by an access control system in order to facilitate staff access and legitimate student access. In this case, it's a high school, students that have been issued access badges, and then can also be operated by the receptionist utilizing a switch. Fundamentally meets all the criteria that I'm describing. Now, what about screening students for contraband entering into the school? In the context of active shooter attacks, that primarily be weapons. This is a very hot issue of discussion throughout the nation. And we have had, over the decades, a number of different urban school districts that have implemented weapons screening for students arriving at school as a standard part of their entry control process. Well, before we decide that we want to go down that road of implementing some type of contraband screening approach, I think it's important to first kind of understand what the considerations are associated with different technologies and doing this in a practical and effective manner. Starting first with metal detectors. Metal detectors fundamentally detect the presence of conductive materials. So that includes the metal, I should say, that is used in knives, guns, and if we were concerned about bombs, IED components. However, that also includes any conductive metal, including belt buckles, including pens, and including other similar types of objects. Thus, it requires that if we're going to be screening people with the use of metal detectors, that all metallic objects or conductive metallic objects have been removed from their body. Now, as far as the practicality considerations, you can typically expect to spend a minimum of $3,700 for a portal metal detection system. In fact, the better ones on the market typically cost north of around $5,000. Now, another important consideration in implementing any kind of contraband screening approach is throughput rate. That's the rate at which we can screen students and keep their progression moving into the school. And for metal detectors, depending upon the efficiency of the screening process, compliance of students, and other similar factors, that could be somewhere between around 15 to around 25 people per minute. And mind you, that doesn't include additional time for rescreening individuals that have been recognized as positives. When an individual walks through the metal detector and it generates an alarm, they need to be pulled aside for additional screening, and that will also increase these times. This is just looking at straight screening through the portal itself. Requires one operator typically in order to direct the actions and monitor people that are passing through the portal. Space requirements in your entry control points, whether that's your main lobby or if you construct a reception point for this purpose, will require for that metal detector about 8 feet by 4 feet worth of clearance for its installation. And that 8-foot clearance accounts for 3 feet on either side of the metal detector for the person queuing, waiting to walk in, and then the next person cannot be screened until the previous person has passed 3 feet beyond the metal detector. That's to avoid generating nuisance alarms. Now, when we look at the volume of students in many schools and the patterns of arrival in the morning, we need to be very, very attentive to this issue of throughput rate and trying to figure out how many metal detectors would be required to adequately screen those entrants within a reasonable period of time so that we don't have excess. We don't have an excessive number of students that are backing up for all purposes or queued waiting to get in. Also, so that doesn't require that we stagger class start times significantly in order to accommodate what would otherwise be a 2 to 3 hour screening process. And that's basically what you're seeing on slide right now. This is looking at the arrival patterns for a school with a population of 1,000. Now, the chart at the top of the screen is showing the arrival of students in 5-minute increments up to the time that school starts in the morning, with the vast majority probably arriving within the period of around 15 minutes prior to around 10 minutes prior to the actual start of the first bell. Now, below that, it shows the number of students waiting, or in other words, the number of students queuing at that time, considering the actual throughput rate. If that throughput rate was 15 scannees per minute per portal, and we were at 10 minutes prior to the actual start of the school day, and we were employing 2 metal detector portals, it is expected that we would probably have 100 students queuing at that time in order to get into the school. If we had a more efficient screening process at 25 scannees per minute per portal, it would require 3 portals in order to accommodate that volume of students arriving for school at the 10 and 15-minute period without any type of queuing or without any type of delays. Now, the metal detection portal is only going to assist us in detecting potential weapons on the possession of a person. the actual student walking into the school. That still does not address the issue of their hand-carried objects. Now, some school districts that employ a screening approach prefer to hand search student possessions. Basically require that a student opens it up and then it's subjected to a little visual inspection, looking for the presence of any kind of obvious weapons or any kind of knives. That is one possible approach. The amount of time required to do so is typically somewhere on the order of maybe around 15 to around 30 seconds to conduct that per student entering into the school. A more efficient approach to this, or a more effective for the purposes of detail, would be the use of an X-ray imaging system. X-ray imaging systems provide a visual image of an object's contents based on density as well as also, with some technologies, material composition. You can expect to spend around $30,000 plus, and depending upon the features of that system and some of the integrated technologies like Z-scan technology and things like this, that cost can accelerate quite a bit. Throughput rate is around 10 to 20 objects per minute, not including any time for hand searching or second searching of any kind of objects that were recognized as suspicious by the operator of the X-ray machine. Typically requires one operator per machine, but most screening protocols used in urban school districts that have adopted this type of technology usually allocate at least one additional officer to conducting hand searching or conducting secondary screening of any objects that were recognized as suspicious. Relatively high training requirements by comparison to the metal detector. The metal detector, it's just making sure that one person passes through appropriately at a time and the next person doesn't step through until the first person has cleared 3 feet. In the case of the X-ray machine, we need an operator that can actually interpret the image that they're seeing, recognizing potential weapons or other similar types of contraband. Typical space requirements at an entry control point would be around 8 feet all the way up to around 7 feet, accounting for both the size of the machine as well as the space for the actual operator. Now, we talked a little bit about throughput rate and what would be required logistically, personnel, equipment, investment, otherwise, to adequately screen a school population arriving for class. Well, looking at the experience and the procedures used in some urban school districts, such as the city of New York, you can get a good idea of what's involved here. Let's say we had a school with a population of 2,000 students. That would require, to work effectively, at least within a 2-hour screening period, would require 3 metal detection portals, 2 X-ray inspection machines, and 2 handheld metal detectors, typically for a cost of around $72,000 minimum, probably closer to $100,000, maybe a little bit more. It would require 9 personnel to conduct the screening of this 2,000 student population. That's 2 officers operating the portal metal detectors, monitoring the students passing through, 2 officers operating the X-ray machines, scanning hand-carried objects brought into school, 1 officer operating a secondary metal detection portal for students that fail the first detector. So anybody that fails the first detector is diverted aside and then they are passed through another portal, monitored by another officer. And then 2 officers, 1 male and 1 female, operating hand scanners on students that fail that secondary metal detector. And then 2 officers serving as facilitators, also looking for anything like students doing pass back on weapons and things like this after another student has passed through the portal system. Now again, this protocol I'm describing for a school of 2,000 students would require approximately 2 hours time and also staggering the first period start times so that students are expected to arrive throughout a 90-minute period of time before the start of school. Now, setting aside the matter of cost, logistics, and all of these other different factors, there is another important issue to consider, and that is the impact on school climate and school culture. And truthfully, that is one of the major reasons why I'm not a strong advocate of metal detectors and X-ray inspection systems in schools. And this issue was actually spotlighted by NASP back in 2013 in their report criticizing high-profile security measures in schools. And in that report, NASP cites quite a bit of support, research, to indicate that the implementation of this type of screening approach does have a chilling effect on school climate and certainly contributes to student perceptions that they are not trusted by the administration or by security. Also, they do cite some evidence showing that it did not result in many school districts where it was implemented in substantial reductions in violent crime or criminal activity within inside of schools. Also keep in mind that many active shooter attacks are not necessarily just launched in the classroom. They initiate the moment a student arrives at school. So simply having a screening protocol in place for weapons does not mean somebody isn't going to arrive at the front door with an AR-15 rifle. And truthfully, this whole climate and culture thing, when I weigh this all from a cost-benefit perspective, that often, in addition to the financial and logistical costs of implementing this type of screening approach, I just often can't justify it. Where I might see it being applicable is in certain school districts where we have a high rate of violent crime. And we've had problems in the past with students bringing weapons to school. So in urban school districts or other locations that have been plagued with this type of problem, then it may make sense. In that case, it may require some significant adjustment to operational issues and budget in order to make that happen. But for the average school throughout the United States, it is my opinion that the risk does not justify the cost, considering these various different factors, logistics as well as also impact on climate and culture. Now, if we have a multi-building, multi-divisional campus, or even a single division campus, but with multiple school buildings, where we may have diverse different personnel, people within the school, that might require flexible access to different buildings, utilizing an electronic access control system can facilitate this kind of versatile need while keeping our exterior buildings in a secure state most of the time. Typically, the way this would work in a school is that staff, and if we have an upper school or high school type division, those individuals would be issued access badges. And then badge readers would be installed in addition to electrified locking systems on different types of access doors or entry doors into the various different school buildings. Now, if we have lower divisions as well as younger, maybe kindergarten age type students, issuing them access badges is not really going to be practical. It's high probability that access badges are going to get lost. Instead, an alternative approach is to program the security management software, the access control software, to unlock exterior doors where younger student access might be required 1 minute before the bell, and then relock those doors 1 minute after class starts. So in essence, we have a time period during each class change where those doors are in an unlocked state, permitting students to move back and forth between buildings, and then once they've entered those buildings and they're in class, the doors lock. Now, this is not a perfect solution because there is a time period between classes where the doors are going to be unlocked, but it at least ensures that the doors are locked on the outside of buildings most of the time. Quite often when I am proposing solutions to clients, and I emphasize making sure that we keep these exterior doors locked, the biggest point of rejection that I run into in many cases, practical matter, is this issue of younger students moving back and forth between classes. Well, the approach that I'm describing is a compromise that effectively addresses this concern. Now, another benefit of utilizing an electronic access control system is the ability to configure a lockdown macro event in the software so that when that lockdown macro event is activated, a number of other different functions occur. Now, where this in schools becomes most valuable, there are often auxiliary buildings inside of our school. For instance, gymnasiums, auditoriums, media centers, and other similar types of locations, buildings, where because of the high volume and diverse nature of entrance into those rooms, doesn't really make it practical for us to keep them in a locked state most of the time. So instead, they can remain unlocked. However, those doors are equipped with electrified locks. And then this way, if the lockdown macro gets activated, those doors automatically all lock throughout the school. So it's a quick way for us to effectively lock down our media center, our gymnasium, our auditoriums, and other similar types of locations. And let me bring up another practical point about this. Quite often in these kinds of buildings I'm describing, gymnasiums particularly, and also in cafeterias, we often find exit bar devices used on steel doors. Often we have double steel doors with exit bar devices. These require a hex key, if they're mechanical exit bars, to be locked. And it is hugely impractical to expect cafeteria staff or the coach inside of the gymnasium to run around to these different doors with a hex key and effectively be able to lock these doors. By simply installing these electrified locks and then utilizing the lockdown macro event, we can ensure that these doors get positively locked quickly when an active shooter or some other imminent threat emergency occurs. Now let's take a look at how we might apply these principles in some different applications. Right now you're looking at an example of an auxiliary building, basically a multi-purpose arts building, where we have a auditorium located inside, and then we also have a separate wing with an art department and a separate wing with a music department. Now, many of the exterior doors, we decided in the design that they're going to be used for exit purposes only, or for staff and utility type access, maintenance, and they will be locked mechanically. That is represented by the little blue dots that you see in the diagram. So all those doors are mechanically locked, operated by exit bar devices from the inside. Then we have other doors that will be designated for use by students in coming to and from class. Those were equipped with our badge readers. Now this is for a high school environment, so all the students are issued access badges in order to gain access to those doors. And then each one of those doors features an electrified locking system. And then we have the auditorium area inside. Now, because of the diverse access that the auditorium often requires, we have drama classes that are kind of coming and going, cleaning and housekeeping people coming and going. We've got facilities and maintenance and other people maybe working on sets and things of this nature. It was decided that it wasn't practical to keep the interior of the auditorium in a locked state all the time. So instead, the exterior doors to the auditorium are in an unlocked state, but they're equipped with electrified exit bar devices that can be operated by the lockdown macro. So this way, if we have an auditorium event going on, like a school assembly, and a threat is recognized, that lockdown macro, once activated in the software, can immediately lock those doors. Thus, we don't have to run around with a hex key trying to lock them. Now, as far as this lockdown macro event that I'm describing is concerned, most modern access control software can be programmed with a lockdown macro event that will execute multiple different functions depending upon how it's programmed. It is also possible that you can install switches or buttons at different locations throughout the campus that can manually operate that without having to go into the actual software user interface. It is strongly recommended that you consider this because one of the things that we will explore much further when we get into emergency response is the simplicity and the reliability of the different procedures we employ under high stress conditions. And relying on somebody to quickly access a computer, get into the software, and activate a lockdown event is just not really practical unless you have a dedicated security control room on your campus. So as an alternative, we can install buttons or switches at select locations, maybe in administrator offices. If we have gymnasiums and media centers, maybe behind the librarian's desk, in a location where it's unlikely going to be activated accidentally by students. Or perhaps in the back of a kitchen somewhere inside of the cafeteria. So that this way, if cafeteria staff or the library staff or anybody else in these auxiliary buildings recognizes some kind of threat activity, they can quickly hit that switch and operate the lockdown macro in order to lock down those doors. And here's how we might apply these concepts on a large multi-divisional campus. Now, on this campus, we have a middle school and high school divisions. We also have a number of buildings. We have a media center, we have athletic facilities, and we also have a cafeteria that all require very flexible access by students. And then we also have a few buildings that are independent staff-only buildings. So what we've done then in the design of the access control system is determined that certain doors will be operated by staff-only badges. These are primarily going to be doors into the administrative buildings, as well as also doors into select areas that would only be used by maintenance or other people like this. Then for the middle school, the doors between, or rather on the outside of the middle school, as well as also select access doors into the multi-purpose science building would be operated with a timed lock and unlock feature. And on that science building, since it's also accessed by the upper division students, it is also equipped with badge readers that can be operated by the high school staff, or rather high school access badges. Then the high school building, where middle school students do not require access, those badge readers will be operable by the use of the high school badges as well as staff badges. And then for those flexible auxiliary buildings, whether it be gymnasium or the other athletic facilities, the cafeteria and the media center, they remain in unlocked state most of the time. That allows students just to freely come and go. However, those doors are then equipped with electrified locking systems that can be operated by lockdown macro when an event occurs. And a lockdown switch was then placed inside of each one of those buildings in a staff-only area, unlikely to be accidentally activated. Just kind of gives you an idea of how we can flexibly integrate all these different elements to accomplish versatile access needs in the school. Now, one thing to keep in mind when adopting the use of electronic access control, or if you already have electronic access control in your school, is hardware selection. And probably the greatest concern that I have in this area is electromagnetic locks. If all possible, eliminate the use of electromagnetic locks in your access control design. And this is for a bunch of different reasons. Well, first let me say, electromagnetic locks are very versatile. They can be easily installed on existing doors in retrofit situations, regardless of frame type, regardless of door leaf type, and other similar types of factors that often limit the hardware options that are available to us. The big problem that I have with electromagnetic locks, actually there's a couple problems. First of all, they fail safe during fire alarms. So in essence, any fire alarm, whether it was somebody pulling a pull station handle inside of the building, basically what happened in the shooting at Washington Navy Yard back in 2013, or perhaps in other incidents too. I'm familiar with a hotel attack where the gunman actually pulled the handle. That also happened at UCF in the attempted shooting by James Sivakumar when he was trying to provoke an evacuation from a dormitory, pulled the fire alarm inside of the building to activate a fire alarm and provoke a response. It could also be the result of gunfire, and that's essentially what happened in the Parkland shooting. When Nicholas Cruz opened fire on the first floor, the fumes that were emitted by his weapon fire and the dust that was in the air activated the fire alarm system. Essentially any other similar type of condition that would otherwise result in activation of the fire alarm will, for all purposes, unlock all of those doors, serving in essence as a master key. Now, the second big problem with electromagnetic locks is when the fire alarm is not going off, it requires either an exit sensor or a push-to-exit switch in order to disengage the electromagnetic lock and permit people to egress. And both of these can be problematic in an active shooter event under high-stress situations. As far as the exit sensors, my team has actually tested exit sensors in a number of different building installation applications over the past several years. And quite frequently, if somebody runs at that exit sensor very quickly, they don't always reliably disengage. That's a big problem. The second, with the push-to-exit switch, quite often we find in the real world these small, tiny little push-to-exit switches that are maybe about 2 inches by 2 inches, green in color, and they are mounted probably maybe a yard to maybe several yards away from the actual egress door. Well, if somebody is running down the hallway, trying to escape from what is a life-threatening imminent situation, their higher problem-solving ability, their attention is going to be impaired. And being able to recognize that small, tiny little switch off to the side of the door, which sounds like a very simple thing, could actually be a complex task or something that otherwise may be overlooked. And instead you got people there at the door, pushing on the door, expecting it to open, not realizing that they have to hit that little PTE. I have also run into some situations where that push-to-exit switch was actually mounted on walls opposite the location of the door or gate it was supposed to operate. The only person who would recognize the location of these push-to-exit switches under high-stress conditions would be staff that were already familiar with the operation of these doors and gates. This is very problematic. Another concern about electromagnetic locks is often the way that they're used on double doors or on banks of doors, where quite frequently a limited number of doors are equipped with electromagnetic locks, and other doors in that bank of doors are then kept in a locked state or are operated by mechanical exit bar. And one example of this is displayed on slide right now. We have a set of double doors. The door on the left-hand side is equipped with an electromagnetic lock, and there's a push-to-exit switch. It's located about 1.5 meters off to the left of this image. You can't see it in the photograph. The other door on the right-hand side is equipped with a mechanical exit bar, and there's a sign on the door stating that this is the only door that can be used for exit. And that is the primary door that as people come and go through this lobby that they use in order to walk outside. Now, the big problem I have with this is that if somebody is running through this lobby under high stress conditions, they're unlikely going to see that little sign that's on the door, and it is unlikely that they're going to see that push-to-exit switch on the wall. So if they run for the door on the left, which does feature a mechanical exit bar, they're going to basically be pushing on it, not understanding why it's not opening up. Now, an example of that, the second type of problem, where we have locked doors. This is a bank of 4 doors. The 2 center doors are operated by electromagnetic locks, and there's an exit sensor that detects as somebody approaches to unlock or disengage those electromagnetic locks. Then we have a door to the far left and a door to the far right that are kept in a locked state all the time. And above this, we have the exit sign. Now, as somebody is running towards this exit under high-stress conditions, it is highly unlikely that they're going to recognize the electromagnetic locks mounted at the top of the 2 center doors. And if they run to the far right or they run to the far left door, they're going to be greeted with a locked door. And they're going to be pushing and pushing and pushing until they figure out that they need to go to the center doors in order to get out of the building. Now, what I recommend is utilizing several alternative hardware choices. One is the use of an electrified exit bar device. These function like mechanical exit bars. They can be pushed from the inside, thus they do not have to fail safe during fire alarms, but they can then be also operated by the access control system. So badge readers will then unlock them. Another alternative is the use of an electrified strike and a mechanical exit bar, whereby the electrified strike is operated by the access control system. Now, truthfully, this would be my second option. I prefer instead to utilize the electrified exit bars, and this is mostly for intrusion resistance purposes. CPNI in the United Kingdom, who studies physical security design and hardware, that's basically their critical infrastructure security organization at the national level, looked at the vulnerability of these different types of locking systems and determined that electrified strikes were very vulnerable to prying and forced entry by prying. Now, truthfully, in an active shooter event, it is unlikely we're going to have a bad guy show up with a pry bar. So in that case, even using an electrified strike should still provide us with a very good level of intrusion resistance against simply a gunman using impact force for entry. Now, our third protective layer in most schools is going to be the actual classrooms, activity rooms, and staff offices, which have been upgraded or designed in such a way as to provide a reasonable degree of delay, intrusion resistance, against the gunman attempting to use firearm, projectile penetration, and physical force. These are the rooms that our students and staff may be refuging in during an active shooter event. Now, there's some basic criteria that all classrooms, activity rooms, and offices that may be used for lockdown purposes should meet. First, they should have a solid core wooden or steel door with a steel door frame. Number two, employing a board or mortise lock set featuring a thumb turn for ease of locking and should be rated at least grade 1 for intrusion for security purposes under the ANSI BHMA A156 standard. Just to kind of explain them briefly, in the United States, the primary standard that's used for rating the durability, function, and also security of door lock systems is ANSI BHMA A156. A156 classifies locks into 3 grades, grade 1, 2, and 3, with grade 1 providing the highest level of protection. So we would want to be specifying a grade 1 lock featuring a thumb turn or a button, and I'll circle back around on that point in a moment. If there are any windows adjacent to the classroom hallways or door vision panels, they should be smaller than 96 square inches and no wider than 1.5 inches and beyond the reach of door handles or locks. Or they should be upgraded with the use of polycarbonate, laminated glass, or anti-shatter film. There should be window shades available, or curtains, or at least cardboard cutouts with appropriate adhesive that can be easily applied to cover those vision panels. And they should ideally also, each room should have good public address system audibility. It is also desired that the classrooms or other rooms that people may be refuging in have telephones with outside dialing capability. And I really like it if we also have an alternative escape option, such as a second door or a window. Although I do describe this as being kind of an ideal condition, because as long as the room meets certain adequate intrusion resistance, it will provide pretty good protection and should be considered safe for lockdown purposes. And this kind of summarizes these various different elements of how they might be applied. So we have a room where size-wise is adequate for the capacity of students. Now, there are actual guidelines for making this kind of determination, which is 5 square feet per person. However, truthfully, in the real world, I don't spend a lot of time measuring rooms and looking at student capacity. What I do look at, however, is whether or not the room is large enough that if somebody attempted to randomly fire through walls and doors, that it will not guarantee hits against students located inside the classroom. Drop ceilings, I don't have a problem with in these short-term type events. Same thing with drywall walls. It is possible that a gunman could climb up on a desk and pop over a drop ceiling to get into a room. However, having studied hundreds of these events over the years, I have not seen that in one single attack. Again, adversaries most often use visually obvious movement paths, hallways, doorways, etc., or visually obvious portals like windows or doors in order to access targets. Windows smaller than 96 square inches and beyond the reach of door handles and locks, no wider than 1.5 inches, or protected with mechanically attached anti-shatter film, laminated glass, or polycarbonate. Window shades or curtains capable of completely covering all windows or door vision panels. Solid core wooden or steel door. It does not matter for short-term applications whether it's inward swinging or outward swinging. And a sturdy board or mortise lock set featuring some type of dead latch system and a thumb turn for ease of locking, such as I described in ANSI BHMA A156 grade 1 lock. Now, why do I emphasize this point about locks featuring a thumb turn or a button, which under the ANSI classification code means office function locks, which would be for board and mortise lock sets, ANSI F04 or ANSI F82. Well, here's the problem. During life-threatening events, the sympathetic nervous system is activated. The sympathetic nervous system essentially governs our fight or flight response. And when it is activated, a whole bunch of deleterious effects occur. First, interferes with problem-solving ability, basically higher cognitive functions. Second, things like tunnel vision begins to set in. memory impairment occurs, and also difficulty with fine motor coordination. And what we quite often find in these types of events is even simple tasks like locating keys and manipulating keys can become challenging, quite difficult, and quite often doesn't happen when a real emergency situation occurs. Now, a lot of schools throughout the nation, especially in the public school world, are equipped with what ANSI calls classroom function locks. These are classified Mortise F05 and Board F84. These types of locks require a key and must be locked from the hallway side of the classroom in order to positively secure. These types of locks should be strictly avoided if all possible. As I noted a minute ago, finding the keys, opening the door, and locking the door under high-stress conditions becomes a complex task. And we have had a number of attacks where these types of locks contributed to casualties. Two good examples, just between Sandy Hook Elementary School and Virginia Tech, 26 people were killed and 24 wounded, specifically because their doors could not be easily locked from the inside. Now, mind you, these casualty numbers that I'm giving you right now, this does not include people that were caught by surprise when the attack commenced. These are people that were located in other classrooms that were unable to secure their room. When they realized an attack was occurring, they could hear it going on down the hallway, and the gunman was able to get inside of the room. For all purposes, these classrooms that I'm describing should have all been locked and could have been had they been equipped with office function locks featuring buttons or thumb turns. So bottom line, do not use ANSI, Mortise F05 and Board F84 locks. Now, if you already have these types of locks installed on your doors and you do not have the budget to replace these locks quickly, there are maybe a few things that we can do to help mitigate this concern. One clever idea that was invented by one of our clients was to take a magnetic strip and place it over the strike plate on the door, and then keep all the doors in a locked state all the time. This way, students can freely move in and out of classrooms during, class change periods or when going to the restroom, this kind of thing. And then, if an imminent threat alert is issued, all anybody has to do is just pop the door open a couple of inches, rip that strip off, close the door, and it's locked. Now, this is not a perfect solution. I would not recommend this as a long-term, indefinite solution, but it is certainly much better than keeping the locks in an unlocked state when dealing with these classroom function locks. There are also certain types of door reinforcement devices that we can employ as well. On screen right now are some different examples. On the left-hand side is an example of two different types of wedges that are marketed for this purpose. The one on the top is called tack wedge. The one down below is actually quite common. I see it being sold by a number of different organizations. Truthfully, I am not a fan of the wedge on the lower left. I have tested it, and when it will secure the door temporarily, but if somebody kicks against that door long enough, it will dislodge and the door will open. The top one on the upper left, that tack wedge, that does actually work quite effectively. If it is pushed into place and kicked, especially with carpeted floors, wooden floors, any type of floor surface that can be easily gripped. It actually has claws, spring-back claws on the bottom side of it that will dig into that surface and hold it in place. On the right-hand side of the screen are some examples of other types of devices. One is designed in order to secure door closers, which are common on double doors. And then we also have below that an example of a pretty nice system that can be installed or put into place and will protect doors that, even if they don't have locks or can't be quickly or reliably locked, against forced entry. However, although I am a strong advocate of that system on the lower right, it does require some more complicated installation by comparison to other systems. Now, door vision panels, again, as we mentioned, should be no larger than 96 square inches. That's actually a U.S. Department of Defense guideline for safe rooms. And should be no wider than 1.5 inches. That's to prevent somebody from being able to break the vision panel, reach inside the door, and manipulate the door handle. If they're not to this specification, then windows should be upgraded with the use of anti-shatter film or some other type of intrusion-resistant glazing, like polycarbonate or laminated glass. One issue that comes up occasionally in working with schools is the subject of ballistic protection. And this was also an issue that came up in the MSDHS Commission report in Florida, where they provided a recommendation for the installation of door vision panels that were ballistic resistant in order to try to prevent a situation such as what occurred where Nicholas Cruz fired through those door vision panels into rooms. Well, on screen right now, you're seeing an example of what the ballistic resistance of different types of common structural materials are. Things that might be used in the walls, for instance, around our classrooms and other areas. Now, the ballistic resistance properties of any barrier are really determined by a couple factors. One is the actual construction material itself and its density, and then also the caliber of the weapon system that's being employed. And on this screen, I've broken it down into 3 calibers, handgun being represented by 9mm, 5.56mm, which is the caliber used in the AR-15 rifle, which has been most common in more significant active shooter events in the United States, and then 7.62 by 5.1mm, which is 7.62 NATO. Not very common in active shooter attacks, but is a popular sporting caliber and military weapon caliber. And then also different types of wall construction materials. Now, drywall standard gypsum board provides no protection against all 3 of these calibers. Bullets will pass right through. Now, concrete block walls, hollow concrete block walls, will provide protection against handguns, 9mm. They will provide temporary protection against 5.56mm. In fact, what happens is hollow concrete block will provide protection against the first few bullet impacts, but eventually begins to disintegrate under multiple repetitive impact strikes. And for 7.62 by 5.1mm, it just passes right through. To have adequate protection against all of these calibers would require either filled concrete block, reinforced concrete 4 inches or more, and brick masonry 8 inches or more. Now, if we are intending to construct ballistic resistant barriers, in addition to using the material specifications on the last screen, we could also specify the use of windows, doors, or fiberglass wall panels that have been appropriately rated under Underwriters Laboratory Standard UL 752, which is the primary standard or the most common standard used in the United States for specifying ballistic resistant materials. Now, if we're using the UL 752 standard, I recommend specifying a material that provides protection against 5.56mm multiple impacts. That'll cover the AR-15 rifle situation, and that would require a UL 752 level 7 rating. The minimum rating that I would recommend would be UL 752 level 5, which would be single rifle impact or multiple impacts against handgun and submachine gun calibers. But truthfully, the cost difference between these two is pretty negligible. If you're going to make the investment, I would just recommend stepping up to the level 7 level. Now, keep in mind, if you plan on installing ballistic resistant barriers anywhere, the weight and framing requirements, the structural construction requirements, are very different from common structural materials. To just give you an idea of comparison, a level 7 fiberglass panel often weighs as much as 11 pounds per square foot, by comparison to standard drywall, which weighs approximately 1.6 pounds per square foot. Huge difference. Same is true also when we talk about glazing systems, as well as also the thickness of glazing systems and framing requirements. Same thing with doors that are ballistic resistant and hinge and framing requirements. Very, very different from common structural materials. And in the MSDHS Commission report, that unfortunately was something that they really didn't spotlight. Now, how often in my work as a consultant do I recommend ballistic resistant barriers? Truthfully, pretty rarely. From a cost-benefit perspective, I would often rather see clients invest in intrusion resistance first, dealing with the locks and the windows and other similar types of barriers, before we start reallocating funds for ballistic resistant materials. But there are maybe some applications where it makes sense. One example might be if we have a situation where we have only a single or a limited number of refuge rooms where a large number of students and staff members are going to be trying to take refuge when an event occurs. An example, I had a preschool a number of years ago that was designed as one large open play space. And then they had one room that was a rest room that all the faculty and the students would take refuge when an event occurred. Well, the problem in this situation is because of the dense group of people that were all packed into this very tiny room, a gunman did not need to get into that room. All he needed to do was fire directly through the door and could guarantee hitting targets on the other side. So in that situation, I did recommend installing a ballistic resistant door for that safe room. But trying to upgrade every door throughout a facility, every door vision panel, every window, it just doesn't make sense. Instead, I prioritize intrusion resistance first. Now, another factor to consider in addition to our barrier design is egress design. Making sure that we have adequate availability of egress routes that are unobstructed, well marked, so that people that are trying to escape under high stress conditions can get out of the area easily. Now, the requirements for egress are dictated typically by building codes, International Building Code, NFPA, and municipal codes. However, keep in mind that even the requirements under these various different building codes, or when they were structured, was largely done with fire in mind, not necessarily with active shooter in mind. And there are some cases where I find things that are permissible under code, but not optimal under high stress conditions where people have minimal situational awareness and are trying to escape from what could be a mobile threat inside of the building. Emergency exits should be clearly marked and easy to locate under stress. In fact, when I'm doing assessments, I will periodically stop in a hallway, usually once every 50 feet or so, and just look around. Can I see a sign directing me how to get out of this area? And if yes, does it point in a correct direction? Is it intuitive? The path and its position directing me to the proper egress route. If the location of exits is not obvious, consider installing extra directional signage. And in fact, that's quite common in a lot of my assessments. If I can't find directional signage easily, or if it's not intuitive, installing additional signage to make sure that we correct the problem. Exit routes and stairwells should ideally be kept clear of obstructions. Although I don't often find major signage problems in schools, blocked exits is something that comes up quite a bit, especially in auxiliary buildings. Things like backstage of theater areas. I run into obstructed exits very, very frequently. Kitchens in cafeterias quite frequently. In other similar types of areas, in other similar types of locations. I've run into it in art rooms quite a bit. Usually, in these rooms where we just have so much stuff that there isn't adequate storage, and instead, teachers or other staff members end up stacking things up in front of the exit doors. Another area where it's very common too is in gymnasiums, where we have so much gym equipment but not adequate storage space, and instead we end up with obstructed exits. But I also find it in other areas too. On the photograph on the right is actually an obstructed exit door located in a main entrance. There's actually a bank of 4 doors. You can't see all 4 of them in this image, only the one on the far right. The 2 center doors, part of what you see in the image, are what is normally used for entrance and exit. And then the doors on the outside, left and right, were locked, and a bench was placed on the opposite side. And there's actually a bench that's on the far left side of this doorway as well. Well, again, if somebody is trying to egress under high stress conditions and they run into this lobby, they're not going to be able to quickly and intuitively distinguish which doors actually can be used to escape and which can't. And if they run to one of the exterior doors to the left or to the right, they're going to be greeted with a locked door, or if it was unlocked, they'd be greeted with a bench on the other side. Up to this point, we've discussed detection and delay elements. We also want to give attention to the response function. Now, there's several different components obviously involved in response. We have the staff and faculty response, including the student response, and then the response by whoever the response force that is going to intercept and intervene that adversary. Now, we'll set aside for the moment the issue of faculty response and student response and address that in the next lesson when we talk about emergency response planning. But I do want to take some time to explore this issue of the response force. Who are the armed responders that are going to be deployed and intercept that adversary when an attack occurs? Now, at the very end of this lesson, we will talk about the integration of physical protection system elements in order to create an effective security design, looking at a live case. When we walk through that case study and we look at the improvement that we receive by having an on-site responder, you will see very quickly just how important that is, that we have quick and reliable response times when these events occur. And that was also kind of highlighted when we talked about different cases earlier in this lesson module. So I strongly recommend, if it is feasible and if it is permissible legally where you're located at, to have an on-site armed response force capable of deploying anywhere inside of the school within 120 seconds of initial alert. Now, this could be school resource officers, if you're a public school type organization, or it could be law enforcement officers contracted maybe from a local law enforcement agency, or it could be armed security officers that have been contracted specifically for this purpose or hired by the school for this purpose. And in the state of Florida, we now have the Coach Aaron Feist Guardian program, which is designed to kind of fill this gap as well. Now, regardless of who these officers are or where we're getting them from, they should meet some very basic criteria as a starting point. As a basic prerequisite, they should have at least a minimum of 1 year experience as an armed security officer or law enforcement officer prior to being assigned inside of your school. That's just to ensure a certain baseline level of experience and training. Second, superior communications and conflict resolution skills. Now, we discussed this in an earlier module when we talked about school climate and school culture. We want to ensure that the officers we're deploying in this school community are integrated within the community in such a way as to neutralize any type of chilling effect on school climate and school culture. Also, keep in mind that they can provide a very valuable service in recognizing conflict situations, de-escalating potential problems. And we also want to ensure that they are approachable so that students feel very comfortable reporting issues of concern. Also, basic CPR, AED certification should be mandatory. They should be physically fit and should have a 90% or better handgun range score. Now, many law enforcement agencies throughout the nation, as well as security agencies and then different state requirements, require somewhere around 70 to 80% proficiency score for weapon qualification. I strongly recommend that you adopt the CIS standard that we use for our officers, and that's 90% or greater. When I have somebody with a gun in the hallway with children, I want to make sure that they're not an adequate or that they have a basic level proficiency, but that they have a superior level of proficiency if they're going to be putting rounds downrange. Now, getting back to that point about the communication skill matter, we, for all purposes, want to be recruiting officers that have the charisma of a teddy bear, yet the defensive prowess of a mother grizzly. We want to make sure that these SROs and armed security officers are specifically recruited for a very rare and unique combination of both tactical capabilities as well as also their interpersonal relation skills. And I will tell you, this is not common. These people that I'm talking about, these officers just don't grow on trees. They're very, very special. And our agency, CIS, has a very extensive selection process involved to find school protection officer candidates that meet this criteria. And unfortunately, looking around the nation, this is something that I see often overlooked. Very rarely do I see in school resource officer programs situations where police departments specifically incentivize officers with this superior combination of skills. And unfortunately, in many law enforcement organizations, the SRO program is viewed as sort of a demotion from other things like other special units or from road duty. This is absolutely a major problem. And it should be culturally viewed as being a promotion. It should be an incentivized type of department action. And that goes for other situations too. I also am familiar with a couple of school districts that have armed security officers, but they have no criteria in the selection and hiring for officers that relates to this matter, this combination of skills. So this is just something very important to consider when you're recruiting officers or hiring officers from a law enforcement agency, security agency, or through your own human resources department. Now, we also want to ensure that those officers have training specific to school protection functions. For police officers, this can be facilitated through SRO training programs, such as the one administered by the National Association of School Resource Officers. If they are armed security officers, and this would also extend to those Florida Guardians, I would recommend that in addition to firearms training, that this also encompass a menu of different types of school-specific security topics, such as principles of school security, laws and liabilities associated with schools, youth social dynamics, psychology, and relationship building. In fact, in our training program for our officers, we have an entire day just dedicated to this issue, including everything from recognizing suicidal ideation, recognizing indicators of abuse, working with students with different types of crisis problems, youth brain development, and a whole huge other menu of things, which are essential foundation knowledge for officers that are going to be working day to day with kids. Then threat assessment methodology, because these officers will play a role on the threat assessment team. Physical security matters, especially as it relates to their function within physical security. Emergency response, not just for imminent threat situations, but the whole spectrum of school emergencies. Everything from fire, tornado, medical emergencies, and all these other various different types of events. They play a role as part of the emergency response team. Emergency medical training. Now, for school protection and school resource officers, I don't necessarily recommend that they have EMT or paramedic credentials. I am at least looking for them to have CPR, AED certification, as well as also a knowledge of how to manage major trauma wounds, such as gunfire wounds, stabbings, and other similar types of traumatic hemorrhage events. Advanced firearms training, as we noted a minute ago, and then also importantly, active shooter tactical response training. Basically, force-on-force training in order to engage and neutralize an active shooter using what's called rapid deployment tactics. And since most school resource officers and school protection officers operate solo as a single officer, those tactics that they're being trained in should not be based on contact teams or more classic close quarter battle team tactics, but instead should emphasize solo operator response. In other words, a single officer moving, making contact, and neutralizing the bad guy. And this kind of gives you an idea of how a program like this might be structured. This actually outlines the school protection officer training that we provide for our officers. First, all of our officers are required to complete 132 hours of prerequisite training, including 68 hours of mandated unarmed and armed security officer training, which is called Class D and Class G license training in the state of Florida. 24 hours then of basic and field officer training as CIS officers. We also have a 32-hour anti-terrorism officer training course. Now, that is a bit beyond the spectrum of just school resource officer needs, but does encompass a number of topics that overlap. And then 8 hours of bomb search training. Then, having completed the prerequisite training, they also then have a core school protection officer training course, which is 34 hours of additional training. That includes 3 days, 24 hours of training in the topics we just discussed. Youth social dynamics, laws and liabilities, best practices and emergency response procedures, and other similar types of issues. And then they receive 10 hours of live active shooter response tactical training, focusing on, again, rapid deployment tactics. Now, in most school environments, the school resource officer or school protection officer is going to be assigned in a patrol type function, having the flexible latitude of moving throughout the school, looking for things out of the ordinary, looking for possible intruders, and responding when an event happens live. Occasionally, however, I do encounter schools that assign officers to static posts. Now, if we are going to do that, if you're going to assign an officer to a static location, that officer needs to be provided with a minimum of 2 to 3 seconds of opportunity to recognize a dangerous situation and initiate a response. This is because it takes the eye approximately 0.2 to 0.3 seconds to see something and the brain to process a response. Then, if it is an imminent threat situation, it requires 1.7 seconds for that officer to draw a weapon and aim and engage with any degree of accuracy. And keep in mind that 2 seconds I just described is under optimal conditions. If they've been standing on post for hours on end, or if they're doing miscellaneous activities like signing visitors into the school, then it is likely that that 2 seconds would be more 3, possibly even 4 seconds for an effective response. Now, why do I bring this issue up? I occasionally encounter situations where schools have posted a critical officer in a location near a main entrance where they are extremely vulnerable to surprise ambush. One example of this was a school a number of years ago that I worked with that had a sheriff deputy in a car at the entrance into the public parking lot. And now they posted that officer there because they believed that he would serve a deterrence function, that he would deter somebody from coming into the campus and causing harm. Well, in the real world, it doesn't really work out like that. Instead, what often happens is that officer posted in that vulnerable location is the first victim when the shooting starts. And that's exactly what we saw in 2009 at the U.S. Holocaust Memorial Museum, when a white supremacist by the name of James Von Brunn walked through the front doors and shot a special police officer, Stephen Johns, before Johns even had a chance to recognize what was going on and even start taking a response. We've had a number of other similar types of attacks as well, exploiting this, such as the attack at the Canadian Centre Block Parliament building, executed by an Islamist extremist who had just shot a soldier across the street, ran to the building, and as he was progressing up the steps, opened up the door and shot the officer that was there in the leg. The officer didn't even have a chance in order to draw a weapon, and then he ran past the officer's position. We've had similar events like this also in Saudi Arabia that I'm familiar with. So to avoid this type of situation, we either want to have additional officers, because that can then respond, which is basically what we had at the U.S. Holocaust Memorial Museum, or if it is only one officer on campus, we want to make sure that that officer is posted in a safe location or assigned to patrol where it is unlikely they're going to get caught by surprise. Now, what about arming teachers? This has become a hot issue of political debate in recent years. And we've been seeing states like Florida adopting and approving arming teachers in the classroom. Well, I, as a security professional, try not to engage political discourse on this matter. You know, often you got gun advocates on one side, and then you have the anti-gun community on the other side of this argument. Instead, I try to focus on what works effectively and what does not. And then I also, as part of that, if somebody does want to adopt a particular measure, how can we do it right, or at least mitigate some of the problems associated with it? As far as the effectiveness issue, there has been a handful of events that were mitigated in schools or addressed in schools by armed faculty. One example, this was the 1997 shooting at Pearl High School, where it was an assistant principal that ran out to his car while the shooting was in progress, retrieved a handgun, and then held the gunman, Luke Woodham, at gunpoint until police arrived on scene. But truthfully, those are very rare events. This was also examined, this response model, if you want to call it that, was examined by the Purdue University team back in 2013 when they did their mitigating active shooter impact study. Now, in that study, they modeled out using agent computer-based modeling several different response scenarios. The first was off-site 911. In other words, call to the 911 call center, off-site police then dispatched to the school, and that they refer to as basic response. The second that they looked at was having a professional responder on site, which they labeled as resource officer. And then they looked at percentages, 5% and 10% of the teacher population being armed. And then they modeled this out utilizing input data from 65 workplace and school shootings. And what you see on screen right now is the results of that study. Now, note, the concealed carry permit holders amongst the teacher population had virtually no, or I shouldn't say no, they had very little benefit by comparison to standard off-site 911 dispatch and police response. The numbers were negligible. What made the biggest difference in this case was having a professional on-site responder, that resource officer, which, when modeled out utilizing their input data, took the response time from 10 minutes all the way down to 4 minutes, and took the average casualty number all the way from around 19 all the way down to around 6. Huge difference. And again, with the concealed carry permit holders not really making much of a difference at all. Now, if you are considering this, there's some things to take a look at and really think through carefully if you're going to do this right. The first is you want to make sure that you mandate some type of experience and training standards. These should ideally be structured to match the training requirements and experience requirements of professional responders. So if we're mandating that professional responders go through, X number of hours of tactical training and they go through X number of hours of firearm proficiency training, firearms handling, and other similar types of issues, our teachers should be mandated to do the exact same thing, to the exact same standards, including qualification standards. The second is also establishing essential policies. Some of those policies, some basic policies, relate to the carry of the weapon. In other words, making sure that it's carried on the body at all times, that it's in a concealed position. Limitations on what types of holsters may be used should also be defined by this, that it's not to be stored outside of their direct physical possession, in other words, inside of their desk drawer or inside of a purse or some other type of handbag. And then also handling of weapons. Every law enforcement agency out there or security department that has armed personnel can tell you about at least one accidental discharge or one situation where somebody set a weapon down on the back of a toilet while washing their hands or something like this. Expect that is going to happen if you have armed teachers in the school. So we want to try to preempt that as much as possible by making sure that we have effective policies in place. Also with this, use of force and rule of engagement policies. Now, use of force is typically going to be dictated by state-level statutes related to the use of lethal force. What I mean in this context is what is exactly the teacher's role and responsibility to respond to an armed threat in the school. Are we expecting that teacher to abandon their class and go seek out a gunman and neutralize him the way we would with a school resource officer or school protection officer? Or is that teacher merely armed for the purposes of protecting their flock, their students in the room when they're in that lockdown state? That should be clearly determined and clearly defined. Teachers need to know what that is. And by the way, my personal opinion on the matter, if you are going to arm teachers, I would do it with the latter type of responsibility, where they are only responsible for protecting their own children. They're not expected to actively seek out and engage a gunman. Then there's also liability and insurance issues that should be carefully considered. When you make the decision in order to endorse or actively arm teachers inside of your school, there are major liability implications associated with that. A lot of that liability gets transferred off to law enforcement agencies or security agencies when they are contracted as outside responders. Your teachers in the classroom, if they are armed, you now assume all of that liability. And then there may be labor and licensing laws to consider as well. One example of this is, depending upon state statutes, does arming teachers now change their classification as an employee, whereby they might now be subject to licensing requirements as security officers, because now they're serving a security function. This, this kind of thing would vary from state to state, but it is something that should be carefully investigated. And then the last major thing to consider, a basic point regarding feasibility. How would this decision be received by faculty and parents, and students too for that matter? Despite the fact that there are many advocates of arming teachers in the classroom in the political realm today, most major teacher, principal, school employee, and similar types of organizations have been very outspoken in their opposition of this. Instead, pushing for arming professional responders, having on-site school resource officers or school protection officers. Also, there have been polls, such as the 2015 poll that was done by CBS News and the New York Times, looking at the general population and how they accept the idea of armed teachers in the schools. And it showed that 57% of all respondents opposed allowing teachers to carry guns inside the classroom. So if we're gonna explore this, if we're considering this as an option, there's definitely some major sober issues to consider first. Now let's take a look at how we can integrate all these different elements, detection, delay, and response, in a practical application. Earlier in this lesson, we talked very briefly about what occurred in the Sandy Hook Elementary shooting. On screen right now, I've attempted to model each one of Adam Lanza's tasks during that shooting event, ending with the time that he actually entered into classroom number 8, the first classroom, and initiated mass homicide. And what I did was I broke it down looking at the estimated time it took for him to complete different tasks, and then the probability of detection. And without getting overly technical at this point, these are the key factors that we look at when determining the probability of interruption as it relates to adversary activity. Is first the delay time, or the adversary task time it's called, and then the probability of detection for these different adversary tasks. So Adam Lanza breaches the glass facade and enters into the school lobby. That took approximately 9 seconds, and there would have been probably a 1.0 probability of detection. You know, it was pretty loud when he fired that AR-15 rifle. Lanza then proceeded through the lobby and engaged staff in the hallway. That probably took around 5 seconds worth of time, maybe a little bit less. Also, 1.0 probability of detection. He then searched the school office and did not see the receptionist, but she was certainly aware that he was in the room. She was actually taking refuge underneath a desk. That took probably around 3 seconds with a probability of detection of 1.0. He then proceeded through the hallway, then to classroom 8. That probably took approximately 4 seconds. And then entered the unlocked classroom, aimed his rifle, and initiated killing. And that probably only required maybe 2 seconds at most, and a probability of detection of 1.0. Now, this brought the total cumulative adversary task time 23 seconds from what would be the first point of detection, which is where he fired and broke the exterior window of the lobby. Now, modeling out the response of activity. When staff called 911 and reported the emergency, it was 09:35:39, at least according to the report generated by the Connecticut State Attorney's Office. How it took approximately 20 seconds in order to issue that report. Then at that point, the dispatcher dispatched local units at 09:36. That took approximately 8 seconds. The police travel time at that point, looking at the arrival time of the first arriving units on scene, was 95 seconds. And then we had the time when those initial arriving units organized into contact teams, assessed the situation, and moved to a side entrance door, entered into the building, and finally moved to Lanza's position. And that took approximately 421 seconds altogether. That brought the total alert and response time to 544 seconds. Well, unfortunately, when we look at this, 23 seconds adversary task time compared to 544 seconds response time, that's a disaster. Obviously, Adam Lanza was already commencing mass killing long before law enforcement arrived on site, or made entry into the building, I should say. And we could actually model this out using the estimated adversary sequence interruption model to derive quantitatively at the probability of interruption of that physical security system, as it were. And that is what you're seeing on slide right now. When this is modeled out, the probability of interruption turns out to be 0.0006. very, very, very low. There's almost no way that the situation at Sandy Hook, as designed and the way it performed, could have resulted in anything other than tragedy. So what could we do in order to mitigate this? Well, first of all, simply looking at the delay times for these various different tasks that Adam Lanza was conducting, these adversary task times, I can see that the total cumulative delay time really doesn't provide much opportunity for that response force at all. So maybe one of the first things I want to do is look at improving delay time. Now, one way we could have maybe did that at Sandy Hook Elementary School was upgrading the exterior facade glazing, those tempered glass windows, with the use of anti-shatter film. That would have improved the delay time by approximately 60 to 90 seconds, depending upon Lanza's skill, depending upon the thickness of the film attachment and other similar variables. The second would be constructing a secure lobby in order to delay access into occupied school corridors, which, depending upon the materials that were used, the intrusion resistance, as it were, of those materials, could delay progress into the school by an additional 60 to 120 seconds, possibly even longer. But we'll say for conservative purposes, 60 to 120 seconds. Then, an important point, replacing classroom function locks. That was the F05 and F84 locks that were on the existing classrooms with locks that feature a button or thumb turn, basically office function F04 or F82 locks. And this was a big problem at Sandy Hook Elementary School, was that you had a combination of both mortise locks and board locks that were employing F05 or F84 classroom function locks. And none of the locks, or at least the locks on Classroom 8 and Classroom 10, the two rooms where we suffered tragedy in that event, did not get secured. So the estimated delay against an adversary using impact force with no additional tools could be 90 to 110 seconds, somewhere around here. Truthfully, it could be longer. I do not have empirical test data for A156 grade 1 locks against an individual just using a rifle buttstock for entry. But based on experience, I would say a conservative number is around 90 to 110 seconds. Now, when I go back and I remodel the original attack that occurred at Sandy Hook Elementary School, but with these improved barrier measures, that takes us from a 23-second adversary task time to now 270 seconds. However, 270 seconds is still less than 544 seconds. Basically, we still have tragedy. So quite frequently, just simply improving delay may not be sufficient enough to accomplish a performance-based goal. It often does require a combined strategy, where we look to improve the delay time through barrier improvement, and then we also look to decrease response time, either through improved communications protocols or otherwise. So maybe probably one of the most beneficial measures would be to assign an on-site response force, basically an armed security resource, or perhaps an armed security officer, capable of reliably responding anywhere on that school campus within 120 seconds of alert. In fact, 120 seconds is the performance metric that I use when assigning school protection officers on campuses. When we assess the geography of that campus, looking at the size of the campus, looking at the volume of buildings, how many levels within buildings, and estimate the time from point A to point B, an officer should be capable of deploying anywhere on campus within 120 seconds. If not, then that requires 2 officers on that campus. And the campus is broken into zones to ensure a 120-second response time. Now, if we work with those numbers and go back to the original event and look at the time required for the 911 call at 20 seconds, 8 seconds for radio dispatch, and then 120 seconds of travel time, that brings us to a total response time of 148 seconds. Now, in this case, when we compare 148 seconds to 270 seconds, we now have an effective system. So in this case, it required a combined approach, improving delay while decreasing response. And if I was to go back and actually model this, again, using the estimate of adversary sequence interruption model, the EASY model, I would end up quantitatively with a probability of interruption of 0.87, which is considered to be very good. So this just kind of gives you an idea of how performance-based physical security planning can be applied in school environments in order to greatly reduce the potential for tragedy during events and support the other activities we're engaging in lockdown response. Thanks for joining us. In this video, we explored important aspects of physical security and access control in schools. In the next part of this series, we'll explore emergency response plans, infrastructure preparations, and model procedures for responding to school emergencies. For more information about the CIS Guardian SafeSchool Program and our work as consultants, visit us on the web at www.cisworldservices.org.